When solving compound OR inequalities, use inverse operations to solve each of the inequalities separately. For this first example, I first need to solve 5x plus 1 is less than 16. To do this, I'm going to first subtract 1 from both the left and the right-hand side. That leaves me with 5x is less than 15. Next, I need to divide both sides by 5. And that gives me my solution to the first inequality, x is less than 3. Values of x less than 3 will satisfy this first inequality. Now, for some reason, it's really common for students to just solve the first inequality and move on, forgetting to solve the second inequality. Don't do that. To solve 6x minus 7 is greater than 23, I first need to add 7 to both sides. That gives me 6x is greater than 30. Next, I divide both sides by 6, and that gives me my solution to my second inequality, x is greater than 5. X is greater than 5 tells me that values of x greater than 5 satisfy this second inequality. They make it true. Now, all I'm missing for my final solution is the word OR. I need to include the word OR to show that in order to be a solution, x needs to either be less than 3 or greater than 5. This final solution is written exactly as I would like. I need to have the less than or equal to on the left, and the greater than or equal to on the right. This is because that matches up with the graph. If I think about graphing this, I would have an open dot at 3 and an arrow to the left, an open dot at 5 and an arrow to the right. So I want my solution to be written to match that graph. Less than statement on the left, greater than statement on the right. Sometimes you'll have to rewrite the two in order to make that be the case. That's going to happen here. Okay, so first inequality, I need to subtract 7. That gives me negative 2y is less than negative 20. Next, I need to divide by negative 2. Uh-oh, I'm dividing by a negative. What happens? I need to flip my inequality. The solution to this first inequality is y is greater than 10. Greater than. When I divided by negative 2, I had to flip. Solving the second one, I'm going to add 2 to both the left and the right-hand side. That gives me negative 3y is greater than or equal to 12. Dividing both sides by negative 3, I again need to flip my inequality statement, as I do whenever I multiply or divide by a negative. The inequality that is the solution to this first inequality is y is less than or equal to negative 4. I flipped my inequality. Now, before I write the word OR, I could write the word OR here, but before I say that I'm done, I need to make sure my less than is on the left and my greater than is on the right. So I'm going to rewrite my solution as y is less than or equal to negative 4, or y is greater than 10. Let's go ahead and graph that solution to see why we did that. So close dot at negative 4, arrow to the left. Open dot at 10, arrow to the right. Having rewritten my solution as y is less than or equal to negative 4 or y is greater than 10 allows my solution to match up with my graph.